So let's take a look at several examples, and that'll help you get a better feel for how we count significant figures. In the first example, we have 120,000. Remember, the first thing we always want to do is look at whether the decimal is present or absent. So since there's no decimal written on the page for this number, we would say the decimal is absent and start counting from the Atlantic side of the number. And we're going to count our significant figures working from right toward the left then. The next thing is we want to start counting with the first non-zero. Well, we encounter several zeros, so we would not count those. And then we hit the 2, so we would start counting with the 2. And then once we start counting with the 2, we count everything in front of the 2 then, so that would include the 1. So in this number, those zeros are all just placeholders, and just the 1 and the 2 would be significant figures. So if we want to answer the question, how many significant figures are in each of the following, then that one would have 2 significant figures. On letter B, this time we see there's a decimal written on the page. And so we would start counting from the Pacific side of the number. We start counting with the first non-zero, and we encounter several zeros again, so we would not count those. We hit a 3, which would be the first non-zero, so it would be significant, as well as the 4, the 5, and the 2, because once we start counting, we don't stop. So this one, those 4 digits we would say are significant. Now in letter C, you might have to pull out your magnifying glass. There's a lot of people who look at this and don't realize that there is actually a decimal on the page because we're not used to seeing numbers like this. But because of significant figures, we're taking a look at a number that is actually from a device going up by tens and estimated to the ones. There's a big difference between 30,000 written with a decimal and 30,000 written without a decimal. So if we want to count significant figures for our original example, the decimal is written on the page, which means that we would count from the Pacific side of the number. And since we start counting from the first non-zero, we would count the 3, and in this case, since we start counting with that 3, we count everything after it. So this would be a total of 5 significant figures. However, 30,000 without a decimal, since there's no decimal on the page, you would count from the right side of the number. And when you start counting from the first non-zero, you wouldn't count those zeros. So the zeros in this case would be placeholders compared to the zeros in the original, which would all be part of the measurement and the estimate. So in this case, we hit that 3, and there's only one significant figure when it's written that way. So that's why it's really important for us to be careful with our decimals and be careful when we're recording our data so that we're representing our data correctly based on the device it came from. So why don't you try D, E, F, and G on your own, and then we'll check them together. So why don't you try D, E, F, and G on your own, and then we'll go back through and check them to make sure that you're counting them correctly. So on letter D, you should have counted significant figures from the left side of the number. The decimal's present, so we would count from the Pacific side. Start counting from the first non-zero, which would be the 8. And once you start counting, don't stop. So all 4 of those would be significant figures. On letter E, there is no decimal written on the page, so the decimal is absent. Start counting from the Atlantic side of the number. Start counting with the first non-zero, which is the 2. And once you start counting, don't stop, so you would count all 4 of those as significant figures. On letter F, the decimal is written on the page, so the decimal is present. We would start counting from the left side of the number. Then you start counting with the first non-zero. Well, those are a bunch of zeros, so we wouldn't count those. start counting with the 6, the first non-zero, and then we would count the 2, the 5, the 0, and the 0, because once you start counting, you don't stop. So those zeros that we crossed out in this case would just be placeholders, while the zeros at the end of the number would be counted because they're part of the measurement and the estimate from the device. On letter G, the decimal is absent, so we would start counting from the right side of the number. Start counting from the first non-zero, which wouldn't be until the 4, so that would be just one significant figure. So the whole point of using significant figures is to use it to round your answers when you do some math to them. So first we want to just work a little bit on rounding. So the directions say to round the following to 2 significant figures. So when you start keeping these numbers to round off, you always start keeping from the left. It would make no sense to start keeping from the right side and keep the 6 and the middle 4 without keeping the first 4, the 40 part of the number. So that's just part of rounding rules. So you start keeping from the left, and we want to keep just 2 significant figures in this number, which means we're going to keep the 4, and then we're going to keep this other 4 here. But we will drop this one off because we don't want a third significant figure. But looking at that very next number, the 6, does tell us that instead of rounding to 44, we should be rounding it up to 45. So rounding this number to 2 significant figures would give us the number 45. There's actually another way we could write this number. We could write it as 45 with a decimal, because in this particular number, with a decimal or without a decimal, actually doesn't make a difference. You would both be, here we'd be counting this, which would be 2 significant figures, and here we would be counting this way, which would also be 2 significant figures. So you could answer either way. There's actually a third way you could write your answer for this one, and this is something that we'll review in a little bit, but that is to put it in scientific notation and write 4.5 times 10 to the first. So if you don't remember how to do scientific notation, like I said, we'll go over it. But if you look at this number, you wouldn't look at the times 10 to the first for your significant figures. You would just look at the 4.5, which means that in counting them, there would still be 2 significant figures. However, with the scientific notation part of it, it would still be the number 45. So it does take care of both things, the number 45 as well as rounding to 2. So let's take a look at letter B and the ways that we could round letter B to 2 significant figures. We would start keeping from the left, of course. So we'd keep the 2 and the 2, and we would want to drop those off because that would be a third and fourth significant figure. So we would run around this one to 22. The immediate next number is a 0.0, which means we would not round it up to 23. And again, just like above, we could write it as 22 with a decimal, or we could also write it in scientific notation as 2.2 times 10 to the first. So that would be 2 significant figures. So on letter C, we want to round this one to 2 significant figures. Now, we just said above that if you see the scientific notation part of it, it is part of the number. However, it's not part of counting the significant figures. So you can just kind of overlook that for just a moment. So when we keep these significant figures, we're going to keep the 5 and keep the 3. And then we would want to get rid of the 4 and the 5 because that would be too many. So we would keep it as 5.3, 2 significant figures, times 10 to the fourth, so that it is actually, 53,000. So could you write it outside of scientific notation? Well, 2 significant figures would be the 5 and the 3. Times 10 to the fourth means that we move that decimal 4 places, so we get the number 53,000. So now we can check. Is it the same number? Rounded correctly? Yes, of course it is. Then we want to check for 2 significant figures. So since there's no decimal written this way, we would start counting with the 3 and then the 5. So yeah, writing it that way would work as well. On letter D, we would keep the 5 and keep the 7, but we would want to round the rest off. Now, a common mistake kids will make is, since we're trying to round the 9 and the 6 off, instead of rounding them off, some students will drop them off and just write the number either 57 or 58. Now, 57 isn't rounded correctly. Since the next number is a 9, it should be rounded up to an 8. But there's a bigger problem in writing 57 and 58, and that's because it's the 5 is not in the tens place. It should be 500 and something. So this one's not rounded correctly, and this one doesn't keep the 5 in the correct place value correctly either. So we would not want to write it either of those ways. So make sure that you keep your numbers in the correct place value so that it's actually 500 something. So instead of rounding 579.6 to 50 something, it should be rounded to something like 570 or 580. In this case, we would round it up to 580. Now, we do want to check and make sure that that is in fact only two significant figures. So since the decimal is absent, I would start counting from this side, and sure, that is in fact two significant figures and rounded correctly. So let's see if there's any other ways we could write this. Could I write this with a decimal on it? Well, if I put that decimal on it like that, all of a sudden that makes it become three significant figures. So although rounded correctly, this doesn't have the correct number of significant figures, so we could not write it that way. Could you write it in scientific notation? Should be able to. You would keep the 5 and the 8 and then times 10 to the second. You would not put the 0 on the end, so you would not put 5.80 because when there's a decimal in the number, that 0 would end up counting. So we would just want to keep the 5 and the 8 if we were writing it in scientific notation. So for this one, you could write it two different ways, 580 without a decimal or 5.8 times 10 to the second. Now on letter E, we have the number 2008. So we would want to start keeping with the 2, and then we want to keep that other place value there as well. It's a 0 currently here. This one's pretty tricky to figure out to round because correct rounding would tell us that if we're going to drop those off, we would want to round it to 2000. The problem with writing 2000, though, is that we're also supposed to have two significant figures for this number. So this is a special scenario that when you encounter a number where you want to keep a 0 significant, but not the other zeros, you have to figure out where to put a decimal to try to make that happen. And there are some incorrect ways of doing this. I get some students who try to make it 20 with a decimal, but that's not the correct place value. It shouldn't be 20, it should be 2000. So that won't work. Then I get some students who try to put that decimal there and, okay, well, let's keep the other zeros there. But that's not the number 2000 either. So how do we write the number 2000 with two significant figures? Some students will try rounding it up to 2100. And that is two significant figures, but unfortunately it's not rounded correctly. So that doesn't work. This is a case where you can only write the answer one way correctly, and that would be to put it in scientific notation. And this doesn't happen all that often. However, you will encounter it where the only way to write the number correctly with significant figures will be to put it in scientific notation. So you can see in the other examples we had, several ways of writing it correctly with rounding and significant figures, but in this case there's only one way to do that correctly. So remember that will only happen when you're trying to keep